Okay, I want to start this one with somebody asking a question, and I want that question to be,
What are we doing today?
yeah, kind of like that, but I want it to be, this word I his system, and I told you yesterday systems are scary, so I want somebody to be like, what on earth is a system? Something like that.
What on earth is a system?
Okay, do it. Let's do it again. Hey, Jacob,
Yes.
do you have a question?
Yes.
What is it?
Oh my gosh, Jacob.
What on earth is a question? A system?
Take
What on
three,
earth is a
take three.
question?
I need the thing to be like,
Yeah,
Take
Jacob's
three.
obviously not the person.
Yeah, Jacob
What on
be like,
earth
I
is a
got this,
system?
and
There
he'll
we
say
go.
something
I
totally
got this.
different.
what on earth is a system is the question. What on earth is a system? We've been doing lots of different algebra stuff, and this is, what we're doing today is going to be quick, and it's just a preview of what we're really going to start is solving systems on Monday. We're going to graph them today. You are obviously not going to graph systems on your Kindles, but we're going to kind of see what they are through graphing them. All right, here's what on earth a system is. A system of equations is a type of problem that involves two or more equations. But I'm going to put two, and I'm going to put or more in a parenthesis, because in Algebra 1, it won't be or more. It will be problems that have two equations at the same time. So we got two equations at the same time, it's a system. So when I say, what's a system? Your brain needs to go, oh, that's when you got two lines at the same time. Now, solutions to a system are pretty obvious. And this is the question I was trying to ask you guys in the back, and you were like, what? I know how to solve them. I don't know what.
Indefinitely many solutions.
Sometimes. Here's the solution to a system. We put two lines down on our graph. And we got like a graph like this. And we put two lines down on them. The solution will be the exact location where they cross. So like here, and then they cross. Oh, there's the solution. So where the lines cross. It's an ordered pair. You got to give me a location. So like if they crossed at 2, 4, you go, okay, 2, 4, that's where they cross. That's the solution to this system. So what is the solution to a system? It is the point where what? The lines cross. The solution to the system is the point where the lines cross. The point where the lines cross. Oh, the most basic way. So when we introduce systems, this is the most basic way to figure it out, is to put them both in y equals mx plus b. We're going to carefully use a ruler, and we're going to graph it, and we're going to see for ourselves where on earth the systems cross. However, this is not the most practical way to do it, because there's a lot of human error when it comes to graphing. Let's see. So, we're going to learn, starting on Monday, we're going to learn the two different methods for how to solve them. That is not graphing. Today we graph, Monday we use different methods. All right, let's look at this system. I got to graph two lines. I got double work, double trouble here. First thing, here's my first equation. I can't graph it like this because it's not in what form?
Y equals mx plus b.
Y equals mx plus b, slope-intercept form. So I need to get it there real quick, and this one's pretty easy to get. How do I get it slope-intercept form?
You subtract 3x.
3x.
Yeah, minus 3x minus 3x. And some of you have kind of got the hang of just knowing if it's 3x on one side, it's negative 3x on the other. So you actually have y equals negative 3x plus 11. And we could circle that. And then you can cross this one out or shade it out. You had to tweak it a little bit. We can't graph it like this. We can graph it like that. All right, the second one, also not in y equals mx plus b. A really easy fix. What needs to move?
X minus x.
Minus x. So it's over here. And you got y equals negative x plus 7. Now we can graph those, and we have graph paper. Find the best ruler that you can. You're going to need it. This is why the rulers are there today. We're going to graph this one. Y equals negative 3x plus 11. Now, just tell me, where is this thing going to cross at?
Negative 3. Or 11.
11. Now, that's tricky. Let's be very careful. You can do it, even though our graph only goes up to 10. Let's just go, okay. That's 9, that's 10, 11 would be right here-ish. Now put a dot on where you think 11 would be. Really, like, right there. Now, what was the slope of this thing?
Negative 3.
Negative 3, which is negative 3 over 1. Which means I'm going to go from this dot where?
Go down 3 and over 1.
And over
And
1.
right one.
So go down 3, right 1, put a dot. Now don't draw the line yet, I want to show you how. Because it is so important that you draw a good straight line with your ruler, what I want you to do is put your pencil on this dot and then bring your ruler up next to it. And aim this thing right through the center of your other dot. You've got to be really exact. And this is why graphing is not the best way to find the answer.
It's A.
Don't work ahead. We haven't even drawn the other line yet. So don't work ahead. See, I mean, I might have missed a little bit, and I was trying to get it. All right, there's that line. I got to draw the other one. I got to draw the other one. So where does this second one cross out? Cross out at 7. So give me a dot at 7. So that's 10, 9, 8, 7. Right here. And what's my slope for this one?
2, 5.
Negative
1.
1. It's negative 1, which negative 1 means I'm going to go where? Down 1 and right 1. So down 1, right 1, and here's another dot.
I withdraw my answer.
Withdraw your answer.
Yes.
Down 1, right 1. And now, honestly, you can go down 1, right 1 again. You'll be here. Down 1, right 1 again. You'll be here. You can almost see where it's going to cross. And it might cross there.
Go down one, right one. It's
Yeah,
cross
down one,
at
right one.
3 something.
So just go ahead and draw this as well. Again, the problem with graphing to find these is you can kind of go, well, other than my own error, I'm kind of close to here. So let's look at our answers. What's the first one? 2, 5?
Yeah.
2, 5. 2, 1, 2, 3, 4, 5. That's pretty close to spot on. The other answer is negative 2, 5. Not even close, right?
I resubmit my answer.
You resubmit. I've decided that I am going to go with A as my answer, right there. Yeah, 2, 5 is the closest. But that's the problem with graphing. We're not exactly on 2, 5 because of human error. Stay on the first page. Stay on the first page.
What?
I want to show you. I want to talk about these two. These are two answer choices. No solution and infinitely many. All right, here's the deal.
No such word.
Here's some recap questions. What is a system?
A system is 2 equations.
2 equations, 2 lines. Now, what is the solution to a system?
Where the line,
where the-
lines
Where 2
lines
lines cross.
Where the lines cross. And then your answer is this ordered pair, this exact location where they cross. However, 2 lines in the world don't have to cross. They could be parallel. Now, if the solution is where they cross and this happens, what do you think you're going to say?
No answer.
Solution.
No answer, no solution. Okay, what about this one? Let's say you graphed your first line. And then you go to graph your second line and you start to realize it's going to be right on top of the first line.
Indefinitely many
Yeah.
solutions.
The solution's where they cross. They're crossing here, and they're crossing here, and here, and here, and here, and here. Infinitely many little points that they could be crossing at. So if you end up with the same line, infinitely many. If you end up with parallel lines, here. Most often, you'll end up with lines that cross somewhere though. So you'll have an ordered pair answer. All right. Preston from a mile away?
Yeah.
All right, Preston, from a mile away. Even further away than Haley was yesterday. Hey, he had the distance just a little bit too far. Too much distance.
Too strong.
Too strong. He didn't know his own strength. Okay, here we go. Second system up. Back page. Let me zoom us way in here, and let's talk about this one. What do you notice about the first equation?
It's in y equals.
It's n y equals mx plus b. Don't mess with it. Don't touch it. That's a good one to start with. What about this one right here?
There's a coefficient on y.
Okay, so what are we going to do about this coefficient on y?
Divide the coefficient off.
Divide by negative 2, divide by negative 2, divide by negative 2. So this one, I'll circle it. I'm going to let myself know I'm ready to graph this one. But like Joby said, let's divide this negative 2 off. Cross out, and I got y equals negative 3 halves x minus 1. 2 divided by negative 2, that's minus 1. So here's my 2. Alright, graphing the first one. Where's my y-intercept at? At negative 3. So let's go to negative 3 and let's put a dot at negative 3. And my slope is
Negative
-1, which means
negative 1 over 1.
-1 over 1. So when I go to graph it, I'll go
Down 1, right 1.
down 1 and right 1. From that location, from that dot, right here, I'll go down 1, right 1. It's basically this perfect diagonal. If you want, put another dot, down 1, right 1. Down 1, right 1. You can kind of start seeing. You could just keep applying the slope and get as many dots as you want. It's going to go right here. Carefully get this line drawn.
Yeah, you come.
Carefully get it drawn.
Oh, I didn't take that time.
There we go. Carefully get it drawn. Now I got to put my second line on. I need to start with the y-intercept, which is what?
Negative 1.
-1. So -1, a dot straight down to -1. My slope just happens to be -3, right 2. So down 3, right 2. From my dot, down 3, right 2. 1, 2, 3, 1, 2. Gets me right here. Carefully graph that the best you can.
No solution. Wait.
Well, it looks like it
No.
crosses
Wait.
right here.
Oh, it does, don't it?
It does,
Oh,
it does.
man. My line
Okay.
ain't great there.
Here's the first thing. Look at your answers. -7, 4. -7, 4. Not even close. A is not. The problem is B and C are really, really, really close. 4 -7 and 5 -7. You be the judge as to what's right. This is the problem with graphing. 4 -7 and 5 -7. Okay. 1, 2, 3, 4.
4, -7.
4 -7. Okay.
Yeah, I'm saying it's 4.
5. We're gonna go with 4 -7.
Yeah.
What do you think they said last hour?
5 -7.
Yeah, they did. And the graph last hour looked closer to 5 -7. That's the problem with graphing is we're in this vicinity, but because of our pencil or our ruler or whatever, we might be off a little bit. So that's why on Monday we're going to learn some of the different methods that you don't have to actually graph these to figure out the answer. It crosses over here. We'll go with B. The unfortunate thing is if you did this on an actual practice exercise, you might get it right, you might get it wrong because of how you graphed it. So, hey, let's see, grab a different pencil. There's a million pencils at your disposal. You have to sharpen it while I'm trying to talk. Okay, you're gonna like this next one though. I'm trying to show you a trick right here. All right, here's this system. First thing I want to show you is this equation right here. If you look at that,
It's just backwards.
it's just this is mx plus b right here. Mx plus b equals y. So it is my equals mx plus b.
It's backwards.
So what you can really do, and what this blank over here is for you to go, hey, that's mx plus b equals y. So really I can just write it as y equals what?
MX plus B.
Which is
B equal 1
1 over
quarter.
4
1 over 4.
minus 6
minus 6.
equals y.
Yeah, y equals 1/4 x minus 6. There you go, that's what we're going to graph. And now the other equation, which you've kind of got the hang of this piece needs moved over there. So the other equation is y equals -2/3 x minus 6. So here's the two equations. Notice something about these two equations. Look at them. Look at both of them carefully.
They both have the same wire.
They both got the same y-intercept. Imagine if you graphed them, we would start at the same spot. We'd go down 6 and put a dot, and then we'd put the slope. We'd go down 6 and put a dot. So wouldn't you imagine they have to cross at that spot?
So it's infinitely.
This one's not infinitely many. This one is just the fact that they have the same y-intercept. That must be the spot they're crossing at. The only way they'll be infinitely many is if they were the same line, and we can tell they won't be the same line. But it is the y-intercept. Now you have to go, okay, what is the location of the y-intercept? This point right here. They both cross here. I don't even have to graph the lines. I know they're crossing here.
0, -6.
Yeah, same y-intercept. You have to be on the ball to tell me, is it 6 Or is it negative 6, 0, or is it 0, negative 6? What is it? Is it negative 6, 0, or 0, negative 6?
0, negative.
0, negative 6. Left, right, none, straight down. So it's 0, negative 6. All y-intercepts start out with 0, comma, some number. And there it is. 0, negative 6. All right, last thing just to wrap it up. First off, tell me, as we go into Monday and you start learning about systems and how to solve them, what is a system? What on earth, Jacob, is a system?
2 equations.
2 equations, 2 lines. Joby, what is the solution to a system?
The point where the two lines cross.
The point where the 2 lines cross. So a system is 2 lines on a graph. The solutions where they cross. Sam, what happens when they do this?
They're parallel and they won't ever cross.
So then we would
No
say
solution.
no solution. And if you graph them on top of each other, Brianna, what would you say?
Infinitely many solutions.
Infinitely many solutions. And that's it. All right, who wants to finish this?
Oh, I got